Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the second phase of video series on Python for Excel users. In this second phase, we will be discussing and understanding the modules in Python. We'll be looking at what these modules are, how to import modules in Python, and what are different libraries and functionalities of Python. So let's see what modules are. Uh, what are modules in Python? In Python, modules are files that contains Python codes. It can have different classes, functions, and variables, and even runnable codes. And to get access to these modules, we have to use import keyword. And to see a module in action, we are going to run OS module, which comes with Python. So we don't need to install it. And to get access to OS module, we will be using import keyword. So let's see how OS module is imported in Python. Here we will come to the command line in Python, and we will use the keyword import, given a space, and OS, and we'll run this. Nothing happens, but a module is imported, which is the OS module. And to see some functionalities of OS modules, we will use some functions of OS modules to see how these work. And a few functions that are common in OS modules are function to see the current directory path in which we are working, which is get CW, and to see the list of directories in the uh, folder which we are working. In order to make a new folder or file in the current directory in which we are working, we use makedir and give the name in the argument of the folder which we want to create. In order to run a function with OS module in Python, we first have to type the name of the module OS, then give a dot, and then use the function which we want to run. So let's see how these functions are run in Python. First, use the get CWD function to see the current directory path. We will first type the name of the module, which is OS, then give a dot, and then type the function which we want to run, which is get CW, and then use parenthesis. Get CW is the function which is used to get the path of the current directory in which we are working. And when we will run this by pressing Ctrl and Enter, we will see the current path of the folder in which we are working. So this was get CW function. The second function is list dr function, which is used to get the list of directories in the folder in which we are working. So to run this function, we will again first type the name of the module, which is OS, then give a dot, and then we will type the function list dir with parenthesis. And when we will run this, we'll get names of all the files which are inside the folder in which we are currently working. So this is the list of all the directories inside the current folder in which we are working. And the third function is make dir function or method, which is used to create a new folder inside the folder in which we are working. So to run this function, again, we'll first have to type the name of the module, then give a dot, and then type the function make dir, and inside the parentheses we will type the name of the folder with which we want to create the new folder. Let's say I want to name the folder as Farhan. So I'll write the name of the folder which I want to give to the new folder, and 1. And when I will run this, I think it's because of the codes. I think I should type this without using codes. So let's see. So let's see. Okay, functions are case sensitive, so I should not use capital letter. Okay. And when I will add an S, I'll run this. So the folder is created, and to see whether this folder is created or not, we will have to run the list dir function again to see the list again, and in that list the new folder would be included in the current folder in which we are working. Let's remove this as it has already been run. And now when we will see this, there we can see a new folder has been created with the name Farhan1. So make dirs function is used to create a new folder inside the folder in which we are working. So we get the result. Now let's see what are modules, libraries, and packages in Python. Different modules and libraries of Python includes Panda. Panda stands for panel data, which we have already discussed. Now we'll see what these panel data are, how these can be compared with Excel, and what are data frames in Panda. So what are pandas? Pandas are panel data and are probably the best tools for data analysis in Python. It allows to sort, transfer, visualize different data, and perform mathematical functions on data. Also play with visualization on data. So it can be considered as improvised version of Excel, because we can do most of the tasks in pandas that can be done in Excel too. And similarly, we can do in Excel what we can do in Panda. So having said that, there are many ways in which Panda can outperform Excel. The basis on which Panda can outperform Excel are the limitations of size. In Excel, we can only process the data which can be handled by the RAM of the system. But in Panda, we can handle data of much more larger size, and which is even larger than the RAM of the uh, system which you are working on. Panda can handle complex data transformations, but in Excel, due to limitation of size, when we work on large files or use complex functions in Excel, uh, Excel starts hanging up and the processing becomes much slower in Excel. In Panda, we can do automation, we can automate different tasks, which Excel cannot. However, in Excel, we can use macros to and create buttons to perform certain tasks. But in Python, it is much more faster and easier. Python is compatible with all platforms, and its codes remains same with all operating systems. Whether we are working on Linux, we are working on Macs, we are working on Windows, the codes of Python remain same. So it is also a notable feature of Python that it is compatible with all operating systems. So these are the bases on which Python somewhat outperforms the Excel. Now let's see what are arrays in Python and how arrays are used to create series and tables in Python. In Python, series are usually named as arrays, and tables or matrices are usually named as data frame. We can say that an array is a series which is a one-dimensional data or one-dimensional series, and data frames are matrices or tables that are two-dimensional data or two-dimensional data set. By saying series, we mean to say that a table which has only one column or a single row, the table is a series, and it is called an array in Python. And by saying two-dimensional data frame or two-dimensional data set, we mean to say that a table which has more than one rows and columns and written as a table is a data frame or a data set, a two-dimensional data set, and it is called data frame in Python. So what are arrays? Arrays in Python are data structure that are usually lists, and lists are usually one-dimensional. It is either a row, which is horizontal form of list, or a column, which is a vertical form of list. So an array is a list or matrix. So there are one-dimensional array, which are series. There are two-dimensional arrays, which are data frames. And in Panda, we usually works on data frames which are two-dimensional arrays, tables or matrices. And to better understand the series that is one-dimensional array and data frame that is a two-dimensional array, we can say that data which consists either of only row or only column is a one-dimensional data set, which is previously said, and it is therefore termed as a series. And a data set which is a table or a matrix which has rows as well as column is a two-dimensional array, as earlier said, and therefore called a data frame. So these are some examples of data frame in Panda. So here is a picture of a data frame which contains the list of students with their roll numbers and marks and percentage. So it is a tabular form of data, or it is a matrix which shows names in columns and relevant data in rows. So it is a two-dimensional array or a data frame, or it somewhat looks like a spreadsheet. Another thing is that Panda is based on zero-based indexing. So in Pandas, index begins with 0. Here we can see that the name of first student, the index number of the first student is 0, and then thereafter it's 1, 2, 3, and so on. So because Panda is based on zero-based indexing, therefore in Panda, index starts with 0. So we can see that on the top of the data frame, there are names of the columns which represents the characteristics of data which is contained in the respective column. And the rows shows the index number which starts with 0 because it's based on zero-based indexing. And the intersection of each column and row is the data value or the data on which we are working. We can store different types of data, which can be a string, which can be float, which can be Boolean, and so on. So in this table, we can see that the data which is stored in the column of a student's name is the name of a student. Therefore, the data type is a string. The second column, which is the roll number of the students, contains numeric data. Therefore, it is integer. The third column is also an integer, contains integer data. And the last column, which is percentage, shows the percentage of the students. Therefore, it is also an integer because it contains numeric data. So this was the example of the data frame which we were discussing in arrays, and we will also be performing and making data frames in Python later in this lecture. And so here we can see that the column names are representing the characteristics of the data which will be contained in the data. Therefore, we can say that in data frame, the names of the columns basically reflects the features of the data which will be contained in that respective column. So in this data frame, above features are student name, roll number, marks, and percentage. So the data frame which is showing the student's name. The feature of the data which will be contained in this column will be the name of the students, and the type will be a string, because these are the names of the students. The second feature, the feature of the data which will be contained in the second column will be the roll number. So it will be integer, and the data type will be integer. The third column will be marks. Therefore, the feature of the data which will be contained in this column will be the marks of the students. And since marks are numeric data, therefore the type of the data which will be contained in this column will be integer, and so on. So the column names represents the feature of the data which will be contained in the respective column, and each row value in a data frame is known as an observation. We can say that the above data frame, there are 4 features and 6 observations, because there are 6 rows. There are 4 columns, therefore there are 4 features, and there are 6 rows, therefore there are 6 observations in the above data frame. 0 to 5, therefore 6 rows. These are 6 observations, and the column name reflects the feature of the data. Therefore, we can say that in this data frame, there are 4 features and 6 observations. So this is discussed there. It should be noted that single column should have the same type of data as for the data. Okay, so here it is saying that the student's name column should contain only the names of the students, and the data type should be of the same type. Here all the data types are strings. This column should not have any numeric data or Boolean data or any other type of data. So we should make sure that the data type of a single column should be same for all observations. In this column, first feature, all the 6 observations should have the same data type, which should be string. In this column, all the 6 observations of the data frame should have the same data type, which is integer. In this column, all the 6 observations of the data frame should have the same data type, which is integer, and so on. So this is discussed here. Why this should be so? Because if data type in a single column is not same for all observations, we might get an error if we insert different types of data in single column. So we should avoid mixing different types of data in a single column or in a single feature, because column is a feature. Here are some of the terminologies which are interchangeable in Excel and Panda, or have same meaning in Excel and Panda. In Excel, a spreadsheet usually called a worksheet, but in Panda, we name it as data frame. In Excel, a column is called a column, but in Panda, it is called series or feature. In Excel, we usually type row heading, but in that is the serial number of the rows. But in Panda, it is named as index. In Excel, a row is a row. In Panda as well, a row is a row. In Excel, an empty cell does not reflect anything, but it is shown as blank. But in Panda, an empty cell, when we run a code, an empty cell will be reflected as NaN, which says that not a number. So this means that in Excel, We work with a spreadsheet, but in Panda, we work with data frames. The columns in Excel are also known as series in Panda. Raw headings in Excel are called index in Panda, and empty cells are NaN, not a number in Panda. So this is the explanation of this specimen or terminologies which are interchangeably used in Excel and Panda, or have same meaning but different names in Excel and Panda. So these were some terminologies uh, which has same meaning but have different names in Excel and Panda. Now let's see how we can create data frames in Excel, sorry, in Panda from scratch. Uh, there are different ways of creating data frames. As we already know that data frame has rows and columns, and columns are series. So referring back to the understanding of arrays, we already know that a series is a one-dimensional array. So to create a data frame in Excel, we have to make use of arrays. And this is the first way of creating a data frame. There are one-dimensional arrays, there are two-dimensional arrays, and one-dimensional arrays are basically columns, and two-dimensional arrays are basically data frames. And to use these array, we use library, which is NUMPY library. So in order to create a data frame in Panda, and in order to use arrays to create data frame, we have to use a library which is NumPy library, which is a built-in library in Panda. So to make use of arrays in order to create data frame, we first have to import this NumPy library in Panda. So here is a example of array, and this is an example of a two-dimensional array which is created after importing the NumPy library. And we can say that to create a NumPy array, two-dimensional array, we have to type the syntax somewhat like this, which is NumPy NP, which stands for NumPy. And to create an array, we have to use a dot and type array. And inside parentheses, we have to provide the values of rows inside a square bracket, which is separated by commas. So this is the way in which we have to write a syntax in order to create a two-dimensional array in Excel, sorry, in Panda, to create a data frame. So this is the example, and the second method to create a data frame in Excel is to use a list array. It is to be noted that when we are creating data frame with list, we don't need to use a NumPy array. Instead, we will directly be using square brackets, and inside a square bracket, we will be writing the values of the data set which we want in our data frame. And the command is written somewhat like this. This is the command and this is the variable in which this data frame is stored. And when we will be running this, we will get an output somewhat like this. So we will be performing all these functions in Python lately. So to begin with the functions, we'll first have to import the panda, and then we will have to import NumPy, and then after importing NumPy, we will be able to create arrays to make our data frame. The second option to create the data frame is to use the dictionaries method. We can create a data frame with dictionaries, referring back to our understanding of dictionaries, which we have already created in previous videos. We already know that a dictionary has two values. One is a key, which is the feature, and the second is the value. So we can use keys as column name and the values as the data which should be contained in respective columns. So the values can be list, dictionary, or any iterable object, and the data will be the many elements inside the list or dictionaries. And in dictionary, a pair of key and a value is termed as item, and we can see that our dictionary has a key and a value which is separated by colon. The key reflects the column name or feature, and the value of that respective key reflects the data which should be contained in the respective column. And in this way, we can create a one-dimensional array or a series. So we can also import data frames from CSV files or Excel files, and it is the third way of creating data frame in which we make use of CSV files. CSV files are files that can be open in spreadsheets like Excel, and this is the easiest way of creating data frames because all the data is already prepared in CSV file, and we will just have to import that CSV file in Panda. So let's see how these codes are written in Jupyter Notebook or Python to create data frame. So to create data frame in Python, we first have to import Panda libraries and then import NumPy library. And after importing the NumPy libraries, we will be able to proceed with creations of arrays in order to create our data frames. So let's import Panda and NumPy in Python. And to import these library, we have to type import and then type Panda as PD. And to import NumPy, we will again type import NumPy as NP as shown here. We have done this here, and when we run this, okay, pandas, I think it's S. Yes. And now we will run this, and here these two libraries are imported in Python. Now to create an array with NUMPY, we will use NP as NUMPY, then give a dot, and then we will type array function, and in this parenthesis we will use a square bracket to give the values of the data set we want to create. And each square bracket encloses a row. Therefore, in first row we want 1 and 4, which is in first row, in first column we want 1, and in second column of the first row we want 4, and let's add more value 1, 4 and 7. In third column of the first row we want 7 as the value. So give a comma and then again open a square bracket. So the second square bracket will show the second row of the data set, and in this we want 2 in the first column of the second row, 5 in the second column of the second row, and 8 in the third column of the second row. Again give a comma after closing the bracket, and use third square bracket to give the values of the third row of the array. Again, we want 3 in the first column of the third row, 6 in the second column of the third row, and 9 in the third column of the third row. And when we will run this, okay, we have to include the entire syntax in the square bracket. Let's see. Now we get the output. So this is the output array. First row, first column 1, first row, second column 4, first row, third column 7. Here we can see that the data set does not have index number and column names. So first, let's save this array with a name, and let's say it's data 01 and give a equals to sign. So this entire data set has been stored in a variable which is named as data 01. And when I will run this, output has disappeared and the entire array has been saved in this data 1 variable. And to get the output again, we will call this data 01 and run this. Now we get the data again, or array again. And in this array, the data set does not have index numbers and column names. So to get the index number and column heads of this data frame, we will have to use pandas and panda data frame, and we will use PD for panda data frame and give an argument. And this argument will be the name of the data set for which we want column heads and index number. So We will do so. We will type pd for panda, then dot data frame function or data frame method, and inside parentheses we will give the name of the data set, that is data01, and when we will run this, it's an error. So we are getting an error. It's because the functions are case sensitive, and here it should be capital and F should be capital. So the syntax should be written like this, and when I run this, I'll get this matrix or data frame. Now we can see index and column heads. That is index number and this is column head. So this is the data frame with index number and column heads. And if we want to rename these index numbers and columns name, we can add further argument in the data frame function inside parentheses. So let's see how we can add further arguments to rename or change the name of index number and column names. We'll copy the same syntax and then modify it to include arguments to modify the names of the columns and the rows. So to do so, after the name of the data set, we will give a comma, and for index, we will type index and is equals to, we will use a square bracket, and then we will give the name of the respective rows inside the quotes. It can be single quotes or double quotes. And for first row, let's rename it for row 1 and give a comma to separate it. And then again open quotes, the name of second row, that is row 2. Then again separate it, open quotes, and then the name of the third row, which is row 3. So we changed the label of the index. Similarly, after the close of the square bracket, we will separate it using comma, then write column to change the name of the columns. Be careful that the syntax or codes are case sensitive. So if we miss S or miss or use capital or small letter instead of respective letter, we will get an error. So there is an S in columns. So write columns, give equals to sign, open a square bracket, and inside a square bracket, give the names of respective columns. And to give the names, open quotes. For first column, it's COL1. For second column, it's COL2. For third column, it's COL3. And when we run this, we can see that the index number are renamed and the columns are also renamed respectively. And so that's the NUMPY. That's the method of creating a data frame using NUMPY in Panda. Let's see how I can create table without using NUMPY. To do so, we'll have to create an array, that is we will simply use a square bracket without using any numpy.array function. And let's see, we will just copy this and paste. And when we will run this, we will get the dataset like this. It doesn't have rows and columns, but it looks like a series. So that's how we can create data frame without using NumPy. But in this case, we won't get a tabular format or a matrix structure of the data set. Now let's see how we can create data frames using dictionaries. To do so, we will have to create multiple dictionaries, and then we will use codes to create data frame. So here we have used an example of populations of different states of United States. So we will create multiple data sets and then use them to create data frame. So we will we will first create two lists and use these two lists to create a dictionary, and that dictionary will be used to create data frame. So we will create a list of names of the state and second list of the population of the respective states, and then these two lists will be used to create a dictionary, and then that dictionary will be used to create data frame. So let's create the dictionaries first, as shown in the example. So we'll come back to the Jupyter notebook, and here we will create dictionaries using a square bracket method, sorry, list using a square bracket method. Inside code, we will type the names of the state, that is California. Second is Texas, give a comma, and the third is Florida. The fourth is New York. The fifth is Pennsylvania. So these are the different states of United States. So when I'll run this, I'll get these states. So now, once we have created this list, let's name it as states. Is equal to sign. So the names of these states are stored in a list which is named as states. Now let's create the second list using the same square bracket method, and that is of the population, and the population of California is 396,13493. The population of Texas is 297,30311. Okay, now since this list consists of integers, so we don't have to use quotes. So I will remove the codes from the first population which I added. The population of Florida 219,44577. Then population of New York 19299,981, and the population of Pennsylvania is 12804,123. So these are the populations of respective states. When I run this, I'll get the list of population and also name it as population. And when I run this, both the lists are stored with the respective names. And to get them, I will type states. When I'll run this, I'll get the states. And when I will write population, run, I will get the population. So now I have to save these two lists in a single dictionary, and to do so I will use the same square bracket method, curly bracket method to create dictionary. And so I will open the curly bracket. To create dictionary, I have to give key and value, separating them with colon. So the first key will be the states, which should be in quotes because it's a string. And to separate this key from its value, I will use colon, and the element that should be in this dictionary should be the names of the state, which is already stored in the list, which is named as states. So I will give the name of the dataset, which is states. When I run this, I will get the dictionary in this form. So the first element or item of the dictionary has been created. Now use comma to separate it. Then to add another element, which is of population, I will use the key population and its respective value, which is already stored in the list, which is also named as population. So I will write population, and when I run this, I will get both the list in this dictionary. So here I have the dictionary. Now, in order to create data frame from this dictionary, I have to again make the use of panda data frame function. And once I have created the dictionary, let's save it or name it as dictionary USA. When I run this, this dictionary has been saved inside this variable, which is named as dictionary USA. And to get the output, I have to use the name of the dictionary to get the output. So here I have saved the dictionary inside this variable, which is named as dictionary USA. Now I will be using panda data frame function to create a data frame out of this dictionary. So to use panda data frame, let's type pd for panda dot data frame. Data frame function is case sensitive, so D and F should be capital. And inside the parentheses, I will give the name of the dictionary which I just saved as dictionary USA. When I run this, I will get the data frame out of this dictionary. So here is the data frame. So this was the video for today. In the next video, we will proceed with the same data frame and we will see how we can create a data frame using CSV file and then how we can apply different functions on the data frame. So this was all for today. Thank you for watching the video. Allah Hafiz.